So we're going to start the heart of dynamics now. So these ones need to kind of bring everything together. We did free body diagrams. From there, we created equations, and then we looked at individual forces. So now we're kind of combine them together. So this is the classic elevator problem. We have a person in an elevator and standing on a bathroom scale. The first one, it says that what is our weight in newtons? So weight, and what weight we feel is basically just our normal force. So if we stand in the elevator, A is equal to 0 meters per second squared. We are not accelerating. So what that tells us is that our force of gravity must equal to our normal force. So when we write out our equation, we say, okay, F net is equal to ma. Right, so we know we're going to accelerate based on the amount of force exerted on us. But in this case, our acceleration is 0. So what forces are balancing out? It's our normal force minus our force of gravity. So since we get 0 is equal to Fn minus Fg, we see Fn is equal to force of gravity. Force of gravity is just mg. M is just 65 kilograms. G is 9.81 meters per second squared. We get a value of 640 newtons. The elevator is going to accelerate upwards. So when it's accelerating upwards, A is equal to 2.0 meters per second squared. So we still have that person inside, but now it's accelerating upwards. Force of gravity hasn't changed, but Fn must be bigger now. And this makes sense because for it to accelerate upwards, it still has to support your weight of 640 newtons, but it has to have a little bit extra oomph to make us accelerate as well. So we still have this equation above. We have this ma is equal to Fn minus Fg. Okay, but A is no longer 0, so Fn is equal to ma plus Fg. Fg is just mass times gravity. So we see we're going to be adding the two up. So we got mass times acceleration plus mass times gravity. So if we plug in our values here, we get a value of 770 newtons. And go ahead, make sure you do it yourself. Make sure you have the same values. The elevator reaches maximum speed and continues to move upwards at a constant velocity. So key thing is constant velocity. Constant velocity means A is equal to 0. If A is 0, forces must be balanced. Net force is still 640 newtons. Okay. And for our last scenario, we have elevators still moving upwards, but now it's going to accelerate downwards. So acceleration is 3.0 meters per second squared. So we have a person in there. Force of gravity hasn't changed. We're still on Earth. But what this implies is our normal force must be smaller. Like the ground is literally falling downwards. It's falling away from our feet. So, but because force of gravity is still bigger than that acceleration, we're still in contact with the ground. Our normal force is going to be smaller. So we say, okay, still have the same setup as before. We have that ma is equal to Fn minus Fg. Fn is equal to ma plus mg. To be careful with this one though, because our acceleration is negative 3.0 meters per second squared because it's going down. Our acceleration is down. We define up as positive. Okay, plus 65 kilograms times 9.81. So we get a value of 440 newtons.